In this video, we'll continue our work with solving systems of equations by graphing. The last video, we solved a system by graphing and we used the method of plotting points. In this video, in this example, we see that the two equations are given in slope-intercept form, and typically we solve them by plotting the y-intercept and then using the slope to get to the next point. So it's important to remember that we are graphing two lines here, right? So I'll try and use two colors. That's the first line. So I'm going to graph that. I can identify the y-intercept as 0, -2. Right? That's right here. That's the y-intercept, what we call b. And then what I need to do is use the slope. So what's the slope of that line? Well, it just says -x, but if I want, I can put a -1 in front of that. And if I want, I can make that a fraction. So I can see that the slope is -1 or -1/1. That means I go to the right 1 and down 1, right? That's rise over run. So I assign the negative to the top and I go to the right 1 and then down 1, and there's my next point. To the right 1 to the down 1. I can do that forever. Okay? And that's the slope of that line, -1, and that's the graph of the line. Okay? So now I do the same thing. I'll use green for this one, green for this one, and I'll graph that line. Y equals 2/3 x plus 3. So I start again at the y-intercept, that's right here, 1, 2, 3. And I'm going to go, the slope is 2/3. That means I'm going to go over 3, up 2. Over 3, up 2. All right, and I do the best I can to graph that line. Straight line. If you're doing this on your own, you want to use a ruler if you can. And then I identify the point of intersection, which is the solution. That's right here. And what's that? That's back 3, up 1. So my answer is -3, 1. You can check that, of course, by plugging it in here and here. So that would be the 1 goes here, the -3 goes here. And make sure you have a match, right? You make sure that works. And then you know you're right. Okay. One more example. Solve this system. So you'll notice in this case, you're given your lines in two different forms. This is what we call standard form, which typically we graph by plotting points, intercepts if we can. And this other guy is given in y equals mx plus b form. I'll start with that one because that one's a little easier. There's the intercept. In this case, the slope is 3, which we can put over 1. That means I go over 1, up 3. Okay, and there is the graph of that line. Now for the first one, let's graph this one. Here's how we did that. We drew our chart, plugged in our zeros. If x is 0, 3 times 0 minus y equals 6. That goes away. Negative y equals 6. Be careful. That means y equals -6. If you want, you can put a 1 there, divide by -1. That's how I got that. Y equals -6. And then I plug a 0 for y. 3x minus 0 equals 6. That goes away. 3x equals 6. Divide both sides by 3, and you can see you get an x value of 2. Plot those 2 points, 0, -6, 1, 2, 3, 4, 5, 6. A little off my graph here. And 2, 0, 1, 2. And I'm going to be real careful when I graph this. And I can in fact see, if I've graphed it correctly, that's not bad, that these two lines are parallel, right? That means they will never intersect, which means they have no solution. So that's my answer for this problem, which you'll see every once in a while. No solution. If the lines are parallel, you'll have no solutions. And in this case, that's what's happening here. They will never intersect. So we just write no solution.